Hello all, in this video we will solve the numerical for preemptive priority CPU scheduling algorithm. So again we have to calculate average waiting time, and this time the algorithm is preemptive priority. We are again going to make use of a priority queue, and the order of execution of processes will be shown through a chart called as Gantt chart. So at time 0 we see there is only one process in the picture, and that is C. So C is there in the queue. Now since there is only one process in the queue, naturally that process will get CPU. And C will start using the CPU. C will continue using the CPU until a new process arrives, right? And a new process arrives at time 2. At time 2, a new process arrives A. Now priority for currently running process C is 5, and priority of newly arrived process A is 3. So priority of A is higher than priority of C, so there will be a context switch and CPU will be given to process A. Okay, so C's execution is still remaining. C want to use CPU for 8 units of time. It has already used CPU for 2 units of time. So the leftover time for C is 6 units. So C is inserted back into the queue. Now A will continue using the CPU at least until a new process arrives in the system, and new process arrives in the system at time interval 4. At time interval 4 we realize that process D enters the system. Okay, now we have to check what is the priority of currently running process. Currently running process priority A is 3, priority for D happens to be 2, right? And priority for C happens to be 5. So the highest priority is of D, so again there will be a context switch and CPU will be given to process D now. So D will start using the CPU. A has already executed for 2 units of time, so its leftover time is 2 more units. So A is again inserted into the queue. Okay, now D will continue executing till time unit 5. Now at time unit 5 process B enters, and we see that when B enters the system, B's priority is higher than D's priority, rather B's priority is highest. So again there will be a context switch. The leftover time for D happens to be 4, right? And now CPU is given to B. Okay, and D is left, so D is again inserted into the queue. Now B starts running. At time interval 6 what happens? E arrives, but the priority of E happens to be lower than the priority of currently running process. So B will continue to run, but E will be entered into the queue, right? At time unit 7 B finishes because B wanted CPU only for 2 units of time, which it has utilized. Okay, so B is done, and now there are no more arrivals happening. So now we are left with C, A, D, E, and the CPU will be given on the basis of priority. So priority for C is 5, priority of A is 3, priority of D is 2, and priority of E is 4. So the highest priority is of D, so D will get the CPU. D will use it for 4 units of time, so that is up to 11, right? Then out of C, A, E, priority for C is 5, priority of A is 3, and priority of E is 4. So highest priority is of A, right? So A will start running again, and A will use it for its remaining time, so that is up to 13, 11 to 13, 2 units of time. And then we are left with C and E. Priority for C is 5, priority of E is 4, so naturally E gets the CPU. E will use it for next 3 time units because it was needing CPU for 3 time units, so that is up to 16. And then finally we have C, and then C will use it for the remaining part, that is 6 more units. So 16 plus 6, that is 22. Now let's calculate the waiting time for A, B, C, D and E. Let's calculate for A. A came at 2, got CPU at 2, but didn't finish. 2 to 4 it used the CPU, but then from 4 to 11 it was waiting. So the waiting time for A happens to be 7. Okay, 4 to 11, that is 7. Look at B. B came at 5, right? B came at 5, got CPU at 5 and finished. So wait time is 0. C came at 0, got CPU at 0, but didn't finish. From 2 to 16 it was waiting. So the wait time is 14, 2 to 16. Okay. Likewise for process D. Process D came at 4, got CPU at 4, but didn't finish. From 5 to 7, right? From 5 to 7, D was waiting, right? D was waiting for 5 to 7. So that is 2 units of time. And finally we have process E. E came at 6, got CPU at 13 and then finished. So 6 to 13 it was waiting. So that is 7 units of time. So that happens to be 21, 23, 30, right? Total wait time is 30. If you want to calculate average waiting time, you have to divide it by 5. So that's 6. So average waiting time using preemptive priority would be 6 in this example. Okay. I hope you have understood this. Thank you.